Good evening to you all. This is the fourth session of this SPSS session, and also what is it? And also the final session of the semester. That means under the uh, business statistics. Right now, today we have to, yes, first of all, I need to say about our plan. Now again, within first sessions, I would like to recover that remaining sessions under SPSS, then especially non-parametric test. Then we can discuss about your assignment and also uh, regarding our past papers and then how to answer some questions and how to interpret output. Then all are very much important for future work. Right now, if I move to the first session, now this is yes again link with the previous discussion. You already you have read these slides, right? These are the criteria for selecting a statistical test, right? Day by day we have to discuss and understand them, because if you are willing to continue this degree with yeah, that means with research component, definitely you have to learn about this. Not only that, then next semester you have project in accounting and project in finance, right? At that time also you have to pay attention on this data analysis, right? Data analysis part. Now here this is the most important slides in this document. Now here, if you wish to apply parametric test for your research, yes, definitely it should comply with the interval or ratio level data, that means quantitative data, and also that means with that level of measurement, it should be followed this normal distribution. Then we can go for the parametric test. Even you have quantitative data, we don't have any uh, guarantee for applying an unparametric test. The reason behind that, if it is not following normal distribution, then you have to go to that second category as mentioned here, right? Now, if you have interval or ratio level data, quantitative data with normal distribution, then you can go to the parametric test. Then that is very much simple one. In your examination also, then you have to provide this type of evidence chart and other. When you are explaining them, it is easy to use this type of chart. Now you should have clear idea about the about this selection of appropriate statistical test, right? Now here, even you if you have interval or ratio level data, but if it is not normal, then we have to go to that non-parametric test, right? Then if your data in nominal or ordinal level data, then definitely you cannot follow parametric test. Then usefulness of non-parametric test and parametric test, it is very much clear. Then how far can we use this parametric test? Then how far we can use non-parametric test is given by given by this slide, right? These are the parametric test and the relevant non-parametric test. When-paired sample t-test, Wilcoxon rank sum test. Unpaired t-test, that means independent sample t-test, Mann-Whitney u-test. Pearson correlation, then Spearman rank correlation, right? Then ANOVA, Kruskal-Wallis test, right? We should have clear idea about this analysis analytical tools. Again, this slide also previously we discussed this slide. This is also very much important. Sometime we are going to measure the difference then correlation or categories. Categories mean sometimes we need to measure the relationship between categorical variables, right? Two categorical variable. For example, gender and smoking. Are there any relationship between gender and smoking habit? Right? These two are categorical data, gender, male, female, the smoking or non-smoking, right? Then two variable here. At that time we need to know, we need to measure the association or the relationship, right? Then if I give some type of example, you should be able to select the relevant statistical test. In this time, in this examination, you are given that type of exercises, cases to identify the relevant statistical test, right? Then based on that criteria, yes, you can identify them, right? Therefore, this chart and the previous chart all are very much important for identifying relevant statistical test. Here if you go to the correlation, yes, you can see parametric correlation, Pearson correlation coefficients, right? Non-parametric one, yes, the Spearman's rand correlation coefficients, right? Then categorical one here, then you can use chi-square test to measure that association. Again, association or relationship, right? Then here, if your target is to measure the differences between groups, then if you have two groups or two or more groups or one groups, then you can use this type of parametric checks here, paired sample t-test, Wilcoxon sign test, right? Then if you have two or more, then you can go to the ANOVA test. ANOVA test. Again, you are given some instructions about this. Here, each and every for each and every parametric test we have alternatives, but here you can see for if you think about your categorical data, nominal ordinal level data, at that time we don't have these options, then definitely we have to go to that non-parametric test. We don't have option for parametric test. Here, if you go to the independent sample t-test, then this is the relevant or parallel Mann-Whitney U-test here, paired sample t-test, Wilcoxon sign rand test. Likewise, we can see parallel test for then ANOVA, then here Kruskal-Wallis test, right? Further, we can discuss how to apply them, right? Right. Now, if we have this type of data set, right? Then how to apply, right? Then you have this type of data set, right? Then one can say, now this is regarding uh, that is depend on this data, right? Then if you think this mean value, one can assume mean value is 150 before collecting data, right? Before collecting data, then one can say now mean value is 150, right? We can test that that amount is correct or not. We can test the hypothesis. What is the hypothesis? Then null hypothesis H naught, yes, is, yes, mu is equal to 50. Sorry, not equal to 50. H1, yes, mu equals 50. Likewise, we can test the, yes, we can test this statistical test, right? Then here it is better to take, right? Then here not only this, then We can practice them, right? You can enter this data into SPSS. How to enter this data? Yes, first of all we can open new worksheet, right? Go to new worksheet, SPSS worksheet, right? Now you can go to the new worksheet. Right. Now without entering that data, now if you assume that now if we have this parametric and unparametric test, right, already entered data, now we can save our time, right? Here you can see that type of variable. Now if we take this one variable as that value, now here if we have reading score here, now one can say now our students has 60 then 60 marks or the 60 score average for reading score, right? Now our task is to test whether 60 is that means assumption or hypothesis is correct or not, right? Then if we go to this one, analyze, right, then compare mean. Here one sample t test. Now we have only one sample, right? We are going to test that 60 is correct or not, right? Then we can go to this again analyze, compare means, and one sample t test, Now next task is to select that variable, whether it is reading score or writing score, you can fill it, right? Now we are going to test whether it is 60 or not, right? Hypothesis, we are going to test 60 or not. You can put here 60 or not, right? Then you can continue them, then click on OK. Now you can see that output here. This is our output. Reading score 52.04. This is descriptive statistics. This is regarding one sample t test. One sample test. Now we test, yes, test value is 60. 60 or not, we are going to test it. Then you can see here we are going to test that hypothesis. No, at that time mu or the mean value is equal to 50. That is the null hypothesis. Null hypothesis, mean value is equal to 50. Then alternative one is mean value is not equal to 50. Otherwise you can say mean value is, now null hypothesis mean value is differ from 50. That means not equal to 50, right? Then here now your answer is 0.00. Again we are using the same criteria. What is the criteria? If it is less than 0.05, mean it is significant. No, significant mean we have to reject the null hypothesis. What is the null hypothesis? Null hypothesis, yes, null hypothesis mu equals 50. Mu equals 50. Then we can reject it. Right? Then as per the results, then what is the decision? Yes, that hypothesis that means reading score is 50 is accepted or rejected. What is the decision? Now this is significant. Significant means we have to reject that null hypothesis. What is null hypothesis? Mu is equal to 50, 60. Right? Now we reject that. Then we have to reject that null hypothesis. It is differ from 60. Final conclusion. It is differ from 50. Now further you can clarify through this descriptive statistics. Real mean value is 52. No? your mean value is 52. Then we have to reject this null hypothesis based on this results. That means our hypothesis is rejected. What is that null hypothesis? Mean reading marks is 60. Now actually it is differ from 60. Further we can clarify through descriptive statistics as well as this statistical test, one sample t-test, right. Then then we can reject that claim. Then one can say now our students capable of yes reading and their average is 60, right. But after testing them we can conclude based on that sample data that average is not equal to 60, it is less than that. Then 52 is the answer, right. 52 is the answer. Is it clear? Then if you give this yes, if you are given this table, then you should be able to interpret them, right. You should be able to interpret them. Then if I send that yeah, that means if I prepare that case, right, this is the output of this study, then at that time test the mean value whether it is 60 or not, right. Then if I ask question to prepare that null and alternative hypothesis and test the hypothesis based on this output, then you should be able to interpret this output, right. Very simple one. What is the decision important factors here to explain here? One is mean value. This mean value. This is regarding descriptive statistics, right, not inferential statistics. Answer is 52. Now we are going to test whether that mean value is 60 or not. Right? You can see test value here, right. Then here you can see then descriptive statistics mean reading score is 52. Now this is the final test, one sample test t-test. Then answer is 0.00 less than 0.05. Therefore we need to reject that null hypothesis. What is the null hypothesis? Then mu equal to 50. Then mu is not equal to 50. That is the decision, right. Not 50, 60. Don't worry about the value. Okay. Is it clear? Can you manage? Right. Now at this time, this is a one sample t-test. One sample t-test. Right. Now we have only one sample, one variable. Then we can make assumptions or the hypothesis based on that. Not only this reading score, writing score also, the math score. Our then math students or our students has yes, student have capable of mathematics. They can earn, yes, their average is more than 70. One can say, or principals of a school or institutions, they can he or she can say now our teachers are very well, then they are teaching well, then mathematics average is this much, right. But we don't know whether that statement is correct. That is a claim. No, claim mean hypothesis. We don't know whether it is correct or not, right. We can collect data and we can run this type of test. Finally we can conclude about that statement, right. Then definitely we have to reject that statement based on this results. Is it clear? Right. Now next one is yes, now we need to compare. Last time also we got that comparison. Again if you go to this yes, this one is okay. Next one here, independent sample t-test. Last time we computed, no? Is it? Okay, last time we calculate that. Have you prepared this document? No. Right. Now, our next task is to measure the two independent sample t-test. Two independent sample t-test. Yes, here we have weight of female, that means 9 female and 13 male. Now one can say males are, that means male's height is greater than female. Or one can say now male height is equal to, not height, weight is equal to female weight, right? Now our task is to test it, right? Then we can say male, the hypothesis, null hypothesis, male weight is equal to female weight, right? That means there is no difference. Now another way, there are a number of patterns. No, one can say male weight is not differ from female weight, right? Otherwise you can say there is no significant difference between male weight and female weight. That is null hypothesis, right? Then otherwise there is a that means equal weight of male and female. Then null hypothesis, alternative hypothesis, there is a significant difference between male weight and female weight. Significant difference, right? Then if we reject null hypothesis, then we have to think with the alternative one, right? Then here please arrange your SPSS worksheet based on these results. Then how to organize this? This is also very much important. Now if we have then you have this right, you have two variables here. One is, yes, how many variables here? Two. What are they? One variable? Yes. First of all, we need to understand them. Then if you assign your worksheet, SPSS worksheet, first of all we should have clear idea what are the relevant variable here and what are the name of them. Yes. How many variables here? Two. Then what are the variables? Yes. Sorry? Female weight and male weight. Do you agree with that statement? How about you? What are the variables? That is the most important thing. Actually, you have two variables. One variable is gender, right? Another variable is weight, right? And gender may be male or female, right? Then when you are going to your worksheet, that means SPSS worksheet, then you can go to the variable view and you can assign that variable. What is the first variable? Gender, then values 1 for male, 2 for female, or F for female, M for male. Likewise you can design your variable view, right? Next one is weight. Next variable is weight, again numeric variable, right? Now prepare that document. Prepare that document. That is very much important. Now simple thing, but those are important. Now here, now if I need to take new worksheet, now we are in the SPSS, then go to file, open, new data, file, new data. Now you can see new worksheet. Now we are going to create a new variable. Your support is very much important here. What is the first variable? Now if it is needed, then you can put here serial number, right? Serial number here. It is not compulsory here for here, but normally we are including then serial number, right? Then what is the main what are the main two variables? First one gender. First one is gender. Second one is weight. Right? Now already we prepared our variable view, design our variable view. Now there are three variable. One is serial number, then gender and weight. Now we can go to the data view. Now your task is to enter that data. Now how many data here? Yes, you can decide 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here 13 males and 9 females. So 13, yes, right? Then, however, this, yes, we have one variable gender. It may be male or female. Then altogether we have 20. Yes, how many? 13 plus 19. No, 13 plus 9 mean 22, right? This arrangement is very much important, right? You should have clear idea to arrange this data set. 21, 22, right? Now we have to design. Yes, we couldn't design that values for gender. You can go to the value column. Yes, 1 for male, 2 for female, right? Okay. Next one, weight. Now we are going to enter real weight. Therefore, no need to give values, right? Now tell me how many. Yes, go to that data set. Yes, female. How many female? 9. No, 9. Now you can select 9 female. 9. No? Then female, 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 up to 9. Huh? Right. Then all others are male. Right. Otherwise you can copy this and block it, right, in this way. Then we can paste, right. Now tell me that weight, right, starting from 135, no, 135. Tell me that values. Your support is very much important, right? 135. Yes. 114. 119. 106. 135. 180. 108. 128. 160. Next 175, 170. 205, 195, 185, 182, 150, 175, 190, 180, 195, 220, last one is 235. Now you can save this, right? You can save. You can save as independent sample t-test, right? Independent sample t-test. Right? Is it clear? What is the problem? If you have any problem, you can ask, right? What is it? Block it. Is it okay? What is the problem? Yes. Go to the variable view. You didn't give that. Here. Click on this values. Go here. Here. This cell. Gender. Yes. Click on this. One. Yes. More. Male. Add. Then type 2. Female. Add. OK. Click on OK. Right. Go to data view. Right. Now you can enter. Just copy. All right. You can decide which is the easiest way, right? Right. Now here you have this you have this data set. Now you should have clear idea about them, right? Just you are given female weight and male weight separately. If you think that you need to enter column like female weight and male weight, that is totally wrong. These two are independent samples, right? Then we need to understand, first of all we need to understand the relevant variable. What is the variables? What are the variables here? One is gender, another one is weight, right? Then our arrangement also based on this identification, right? Now one can think now female weight here, another column male weight. Yes, in that way we cannot analyze using statistics, that means SPSS, right? These two are independent sample, therefore our sample size is not relevant to that 9 or 13. Actually our sample size is 9 plus 13, 22, right? Among them 9 are female, 12th, 13 male, right? In that way you can identify it, and now you can go to this worksheet, right? Now if you go to this worksheet, right, now you have complete worksheet including three main variable: serial number, gender and weight. Can you manage? Can you prepare it? Now our task is to write. Then I am suggesting to apply independent sample t-test, right? Actually you cannot apply independent sample t-test without testing the normality, right? But we assume that now our data set is following normal distribution. Under that, that is subject to that condition, we can apply independent sample t-test only for this teaching purpose. But if you are doing your own research, right, if you do your research, then at that time definitely you have to test the normality. If your answer is yes, then you can go for the parametric independent sample t-test. Otherwise you need to go to the non-parametric man-Whitney u-test, right? Now now we can go to this analysis. Then how to perform this independent sample? How to perform it? Analyze. Here compare means previously we got one sample, now independent samples we have two, male and female, two categories, right? Then therefore we need to select independent samples t-test, independent samples t-test. Then click on this independent sample t-test. Here we need to select that variable, testing variable. What is the testing variable here? Weight. We are going to test the weight. What is the categorical variable? Actually we have to mention as categorical variable here. What is the categorical variable? Gender. Then you can see question mark here. Then we have to define that categories. Now how many categories here? We have one category male, one for male, then two for female. As we assign here, then again we have to fill these boxes, right? Then if you click on this continue and OK, right, now you can see that values, right? Now you can get some idea about the mean value, mean weight of male and mean weight of female. How far differ them? Mean weight of male is too high, it is 89, 189. Then if you move to the female weight is comparatively less, 134. Then after reading these statistics, we cannot say it is statistically, that means statistically significant difference, right? Now we need to go to this independent sample t-test, right? If we go to here, finally we can conclude there is a significant difference between groups or not, right? Here just we can identify about the mathematical difference. Mathematical difference we can identify through that descriptive statistics. Here this is the independent sample t-test. Then there are number of tests here, then t value. Then it is again it is important to take this p value. Now your p value is 0.000. Again 0.00 mean it is less than 0.05. It is less than 0.05 mean significant difference is there. That means we have reject null hypothesis. What is null hypothesis? There is no significant difference from the significant difference between male weight and female weight. That is the null hypothesis, right? You should be able to build that hypothesis, right, based on this detail, given detail, right? Then alternative one is yes, there is a significant difference from the significant difference between weight of male and female. Right. Now, if our answer is 0.00 mean, yes, we need to reject that null hypothesis. We are rejecting which hypothesis? Yes, there is no significant difference. Then we reject that. Therefore, there is a significant difference. It is proved by this uh, descriptive statistics. If you see this mean value again, yes, it is proved. Then then you can say male height is male weight is higher than, yes, female weight. Then otherwise you can say there is a significant difference between male weight and female weight, right? There is a statistically significant difference between male weight and female weight. Is it clear? Then here when if you are reading this document, actually you can see two options here: weight, equal variance assumed, equal variance not assumed. Equal variance is assumed mean, yes, at that time we assume now equal variance are in this sample, but again it is rejected. That's why our answer is 0.00. Then we need to go to the second row. Second row is called 0.000. Then again then we can reject that null hypothesis. That means there is a significant difference between weight of male and female. Is it clear? Right. Now you are given one database. You are given one database, that is parametric and non-parametric database. Reading score, writing score, gender, you are given that. Right. Now I need to know whether there is a significant difference between male reading score and female reading score. Now you can test it. Please run them. Right. Now you can take that database, right, from your LMS, parametric and non-parametric database. It has reading score and another categorical variable as gender, right. Then first of all you need to refer that categorical variable gender, whether it is under F and M or 1 and 2 or 0 and 1, you have to define it, no? Right. Then first of all you need to know. Please refer them. Right. Now you can see. Right. Reading score. Here reading score. Then another one gender. Right. Now you can go to the variable view and you can identify their rating system. 0 for male and 1 for female. Right. Then when we are defining them, we have to assign 0 and 1. Right. Now if you go to this, right, now I need to identify the difference between male reading score and female reading score, whether it is statistically significant or not. I need to know about them. Right. Now my first task is to go to analyze, then go to compare mean, then independent sample t-test. Independent sample t-test. Then select reading score for the testing, then gender for grouping. Gender for grouping. Then we need to define it, click on define, then we need to assign relevant value 0 and 1, right. Now click on OK. Now you can go to the output viewer, click on that output file, you can see bottom of your page. Now here male reading score is 52, female reading score is 51. Actually, if you think about here, we cannot see mathematically, yes, mathematical difference here, big difference here. However, we don't know whether it is statistically significant or not. That is depend on degree of freedom and this number sample size, and there are number of criteria, standard error and all. Right now, you can go to the that variable here. Again, this is equal variance. Assume now it is not significant. That means there is a equal variance. Now we can use this column, right? Yes, we can use this column. Now your significant value is 0.64. That means 0.64 means it is not a significant one. What is our null hypothesis? There is no significant difference between male marks, reading marks and female reading marks. Now here we cannot reject null hypothesis. That means we don't have enough information to reject null hypothesis, right? Your answer is greater than, the p value is greater than 0.05. Then we don't have enough information to reject that null hypothesis. That means we have to, yes, that means we can say there's no significant difference between female reading score and male reading score. Is it clear? Now we computed same thing for previously for weight, now for reading score, right? Reading score. Now your turn. Now actually I operated that process. Now your task is to measure the statistical test, run the statistical test for identifying difference between writing score of male and female. Writing score of male and female. How to perform it? Right now, in the same database, you have writing score and gender. Writing score and gender. Writing score and gender. How to perform? Again, select writing score. Go to analyze, compare mean, analyze, compare mean, independent sample t-test, then select test in variable. What is the test in variable here? Writing score. Then group in variable is gender. Then assign 0 and 1, no? 0 and 1. Then again you can see independent sample output, right? Then tell me your decision. Previously we don't have enough information to reject null hypothesis. That is regarding reading score. Now we are going to test about the writing score. Are there any significant difference between male writing score and female writing score? Right? Then prepare that hypothesis, null and alternative. Null hypothesis, there is no significant difference between male writing score and female writing score. Alternative one, there is a significant difference between male writing score and female writing score. Right. After running them, you can see that tables. Please save that table in your folder or desktop, and finally you can copy this into Word document. Then your task is to interpret it, right? Please interpret this output in your Word document, right? You can write all those things, then just you can copy into Word document and you can write something about them. right? What is your decision? Whether we are going to reject null hypothesis or accept based on the results. You can write, right? Right. Now, tell me your answer. Reject. Reject null hypothesis. What is the reason? Answer is less than 0.05. Right? Then what is the decision? There is a significant difference between male writing score and female writing score. Is it clear? Again, we can do the same thing. Sorry. Analyze, compare mean, independent sample t-test. Now you can see the existing one. Instead of reading score, just you can replace writing score. Just click on OK. Now you can see, yes, answer is 0.00. This is 0.00. Then we can go to the equal variance not assumed. Now this is the relevant column row here. Then answer is 0.00. That means you have enough information to reject null hypothesis, right? What is null hypothesis? There is no significant difference. Actually, we can see now as per the results, we can see significant difference between male writing score and female writing score. Is it okay? Right. Right. Now we complete. Now you can continue with yes. This is for mathematics score here. Mathematics score, science score, social studies score. You can continue. You can practice them. Right. I am not going to waste my time to discuss them. Then your task is to practice it. Right. Right. Now again, I want to move to that document here. This is regarding independent sample t-test. Independent sample t-test. Right. Now, if you think about the paired sample, right? Then we should be able to compute that type of variables, right? Now, how to create that type of variable? First of all, you can right now you can go to the existing database and we can open new variable, new worksheet, file, new data. Right now we have new variable. Please save previous one, right? By using your own name, file, save as, then put that name, right? Right. Here, if we assume that now in this case, your application is correct, right? You told that. Now, how to assign that paired sample t-test? Yeah. Then before and after, we should arrange two columns. Same variable before and after, same person, right? For example, now if I ask a question, your talent or the awareness about SPSS before starting this lecture series and after that. If you have a particular measurement or marks, then you can assign values. You can assign values. After that, we can measure the relationship, measure the difference between before the training program and after the training program, right? You may know about that number of training programs, training and development programs in your organizations, right? Before going to that particular training program and after that program, you can measure the performance, right? Now, if you assume that performance before your training program and after your training program, right? Now, if we assume that, then we can arrange our variable view for three variables. How to arrange them? First variable, again serial number, serial number, serial number, right? Then second variable is uh, that mean how to assign them training program, training period, training period, or time, right? We can assign two variable, one before the training, second one after the training. After the training. Then click on OK. Then third variable is uh, if we assume that performance, job performance, job performance, job performance, right? Now we have three variable, one is serial number, another one is time period, time, it is better to take time, right? Time, then job performance. You cannot put space in between job and performance, right? You know that accepted and rejected characters, no? Right. Now if you go to the data view, please if you assume that 20 workers, right? 20 workers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? Now if you reduce that decimals, you can see that right, we have 20 workers, time before and after, right? Here we should have time, not 1 and 2, right? Here actually we need to change it as time. It is better to take time before, right? Remove these values, right? Here it is better to write here before the training program, before the training, right? The variable should be performance, job performance. Job performance 1, next one job performance 2. Then right, you can copy this one and you can change as after the training program, right? Performance before the training program, performance after the train program, right? Now we have three variables. If you go to here, first one serial number, second one job performance before the treatment, right? Then after the treatment, job performance after the treatment. If you take here before and after, it is easy, right? Type here before and after. No, it is not a problem, right? But you have clear idea after, right? If you change it, now you can see before and after, right? Again, go to variable view. First one serial number, second one before, that mean before mean performance before train program, after mean performance after train program. Now you can go to the data view. You can put here assume data. Now if we assume that, now if we are going to assign values for the performance out of 100, then if you think about first person, their performance before the training program is 44, then after the program is 55. Here 55, then 57. Another one 34. Here 33, no improvement. Another person 56, then 72. Another person 39, 49. Another person 56, 78. Another person 32, 35. Another person 36, 34. Another person 48, 61. Another one 46, 57. Another one 66, 76, 68, 68, 78, 87, 67, 76, 35, 53, 45, 47, 33, 38, 76, 87, 66, 67, 55, 50. Now we assign value as per our view, we can enter that data. But if you are doing your own research, then you have to collect that data from real sources, right? Real sources. Then if you collect this data, right? Now we have serial number, performance before the training program, performance after the training program. If you go to here, you can see performance before the training program, here performance after the training program. Now you can run that test, paired sample t-test. Now you have paired sample. This is not an independent sample t-test. Independent means we have one categorical variable, another variable that is under the ratio interval level. Here we have two quantitative variables, but same person, right? Serial number mean person 1 to 20, right? The same person before and after, the performance of same person before and after. These two are not independent, dependent sample. That means repeated sample. If you have repeated sample, at that time you can go for the paired sample t-test. Paired sample t-test. Then analyze. Compare means now we can see the fourth one, paired sample t-test. Analyze, compare mean paired sample t-test, right? Analyze, compare means paired sample t-test. If you click on this, now our task is to select that variable, couple of variable here. One is performance before train program, you can select it and click on this small arrow. Again, second one is performance of after the train program, click on this small arrow. Now you can see first pair is completed, variable 1 and 2, right? Just you need to click on OK, right? Further you can see these details, right? Click on OK. Now you can see this table. You are given 3 tables. First one, this is regarding average train marks before train program 51.75, after train program 59, right? Now we can see mathematical difference, but we don't know whether it is statistically differ, right? Now correlation is 0.908. Now finally your answer is significant. Again p value, very simple thing here. You can think with that p value. P value is 0.00. P value is 0.00. That means, yes. Then what is the null hypothesis? Again, build that null hypothesis. Take down the, what is the null hypothesis? Take down H naught null hypothesis. Yes. There is no significant difference between, yes, between before the performance of workers or the employees before the training program and after the training program. So one can say then training does not affect to the performance, right? Another one, affect to the performance, right? Now we are going to test it. Your p value is 0.000, then again less than 0.05, then we have to reject null hypothesis. What is null hypothesis? There is no significant difference between yes, that means before and after train program. That means we can see significant difference of employee performance after the train program. Then success of the program. Is it success? You want 0.00? Right. Okay. Now don't worry about that value. As per my value, my answer is 0.00, right? Then your value is 0.66. That means it is, yes. That means no significant difference. Then we have to accept null hypothesis. That means no significant difference. What is the finding? It is not effective one, no? Effective training program. If as per my answer, yes, it is an effective program. Is it clear? Now in your organization also there may be number of workshops, no? Then before and after you can test their performance or satisfaction, right? You can select the relevant variable, right? Then before and after. No, not only this, now if you think about the agriculture things, before applying, yes, before then you can use two paddy field, that mean piece of land for that, then without applying fertilizer, then with applying fertilizer, what is the harvest? You can test, are there any significant difference between these two method, right? Then this knowledge is very much important for your practice as well as research work. Is it clear? Right. I think now you already completed three parametric test. Parametric test. Next one is here. If you go to this one again, if you go to the yes, you can see here. If you refer this document, right? There are four groups. There are four groups, right? And their marks, right? Now, if I ask a question, are there any difference between groups, right? Then we can get this idea through ANOVA test, analysis of variance. ANOVA mean analysis of variance, analysis of variance, ANOVA, right? The relevant test for here is ANOVA. Right? ANOVA. You cannot write simple words, right? Simple letters. ANOVA mean analysis of variance. Analysis of variance. Then are there any difference among groups, right? Then here actually I plan to enter this data set, and finally we can analyze through SP, that mean ANOVA, but I think this is not not the time for wasting them. Yes, we can use ANOVA analysis of variance through these existing data sets, right? You can see one data set as here ANOVA here. If you click on this here, in this case you have please click on this ANOVA worksheet, SPSS worksheet. Do you have that? You can upload it, so download it. ANOVA, yes. Double click on this ANOVA database, right? Now you can see sales in million or the quantity. Don't worry about the value. Here you can see numeric value. Next one, design. There are how many design here? There are 4 designs. There are 4 designs. You can, if it is needed, you can name it. Right? There are 4 design. You can assign design A, design B, C, design C, and design D likewise. Otherwise, design you can enter design 1, design 2, design 3. There are, yes, how many designs? 4 designs. Then left hand side you can see sales. Then next one here, store size. Store size also we have 5 sizes, right? But if we take first and second elements, second variables, sales and types or design, are there any difference between sales value and or number of units? Now here you can see number of units and that means demand for different designs. Are there any difference between designs, right? Right. How to compute them? Again, we have numeric variable and another 4 categories, right? Don't worry about this value. Now here instead of 1, 2, 3, 4, you can assign A, B, C, right? It's okay, right? Now if we need to perform analysis of variance, go to analysis. Here compare means last item is called one way ANOVA, right? If you click on this, then our task is to select this dependent variable sales. Then next one is categorical one, design. We have 1, 2, 3 designs, 4 designs. No, here you can see. Then if you click on plots and HOTS, then you can select this Beneferrani. This is a very common one, and Turkey, right? Here, if you click on OK, continue, and you can see option descriptive statistics here. You can select it, right? If you need descriptive, fixed and random effect, homogeneity of variance, you can select it. Then if you click on OK, now here you can see descriptive statistics, then type 1, 2, 3, 4, their mean value we can see 14, 13, 19, 27, right? The standard deviation and other variables here, 95% confidence intervals also there. Now second one, test of homogeneity. Now this is the important one. Yes, whether there is a significant difference between within groups. Yes, again final decision is here. Your final answer is 0.00. That means yes, we can see significant difference between groups. That means significant difference. Again, we can see this Turkey and Beneferrani test. Based on that post hoc test, actually we are going to post hoc test to identify the differences between significant differences between groups, right? Now if you go to here, group 1, as per the Turkey test, group 1, yes, design 2, then you cannot see significant difference. If it has significant difference, you can see this asterisk. Actually you can see significant difference between first and fourth one. Asterisk mark here. Asterisk mark means the mean difference is significant at the 5% level. You can see this reference, right? Then here if you think about the second design differ from fourth one again asterisk mark here. Third one, it is yes, again differ with that same variable, same category, that means same fourth design. Then fourth design differ from each other, right? Then this post hoc test, now similar results you can see from Beneferrani test also, asterisk marks, right? Then if you select that post hoc test, at that time we can identify the differences between groups, right? Then if we have ANOVA test, previous one table ANOVA test, you can say whether it is significant, that difference is significant or not. Within that group we can see significant difference, but that difference we can identify through this post hoc test, right? Again, I'll do the same analysis again. Please consider this process. Right? Then analyze. Compare means one way ANOVA. Then select dependent variable, dependently sales, and design is the factor variable or categorical variable. Then go to the 4-stock test. You can select Benefirani test and Turkey test, right? Then click on continue, and if you go to the options, you can select descriptive statistics. Then click on OK. Then again click on OK. Now you can see this test. Now if you don't select this post-hoc test, we have only this descriptive statistics and ANOVA table, right? Due to this selection, you can see post-hoc table too, right? Then you can identify the difference between groups. Actually, we cannot identify difference between 1 and 2 groups. Design 1 and design 2, design 1 and design 3, but we can identify difference between 1 and 4, right? Likewise, we can identify that difference through this Turkey test and Benefirani test. Here, if you refer this ANOVA table, overall difference, whether it is significant or not, we can see overall significant difference between groups and within groups, right? Now we completed 4 main parametric tests, right? Now this is the time for discussing non-parametric test. We have number of parallel non-parametric tests for each method. Now if you go to this one, yes, here parametric test, paired sample t-test, then Wilcoxon sign test. Then independent sample, unpaired mean independent sample t-test. This is the Mann-Whitney U test. There are number of Pearson test, then SPMS RAND correlation. One-way ANOVA, Kruskal-Wallis test. Likewise, we can see number of non-parametric tests. Number of non-parametric tests. Right? Now, if we move to independent sample t-test, we got that independent sample t-test. What is that? Yes, this one, no. Right. Now this is the independent sample t-test, no. Before applying independent sample t-test, actually we need to test the normality. How to test it? Right. Last time I told you the way of selecting non-parametric or parametric test. What is the selection process? Then first of all, we need to test the normality. Normality test. Normality test. Then your answer is no or yes. If it is yes, you can go to the parametric test. Then if your answer is no, then you can go to the non-parametric test. Right? Another criteria here, you may have nominal data ordinal data or scale data. Scale mean yes ratio interval or ratio level data, right? Then if you have ordinal or nominal, you have to go to the non-parametric test. Then here you can go to the parametric test. Even you have this scale data, then you have to go to this test. After testing them, answer is yes, you can go to the parametric test. Then if your answer is no, then you can go to the non-parametric test. Is it clear? Right. Now here we consider the scale of measurement, that in measurement scale, and here normality. Two concepts here we combine together. Right. Now here in the same issue here we have same issue with this yes your independent data sets. You can save as here independent sample, save. Now we have this data set. First of all, before testing before applying parametric or non-parametric test, we have to test the normality. Then how to test it? Analyze descriptive statistics. Third one is called explore data. Analyze descriptive statistics, explore data. Right. Now you can select dependent variable, yes, weight, right. Then click on plots. You can select plots, normality, plots with test, normality, plot with test. Then click continue and click on OK. Right. Now you can see this descriptive statistics, mean, median, mode, and all descriptive statistics. This is the most important test of normality. Test of normality, right? Then in your examination also, if I give this type of table, you should be able to interpret that results, right? How to interpret this type of results. Now, what is the null hypothesis and what is the alternative hypothesis? That means this is with normal distribution, that is the alternative null hypothesis. That means it is not differ from normality, right? Data set is following normal distribution. It is not differ from normality. That is the null hypothesis. Alternative one is yes, it is not follow. It is not that mean following normal distribution. It is differ from the normal distribution. First one, it is not differ from the normal distribution. Here, alternative one, it is differ from the normal distribution. As per your answer, yes, your answer is 0.20. 0.2 mean greater than 0.05. Greater than 0.05. Is it clear? Greater than 0.05. Therefore, you cannot apply non-parametric test here. We already applied parametric test. That is correct. Right? Is it clear? That means this is following normal distribution. This is following normal distribution. Most of the value on the now your answer is Here you can see, yes, further you can take one example, right? Please go to your previous data set, parametric and non-parametric data set, parametric and non-parametric. Here this one, reading score and writing score, you can see. Then if you take one reading score or writing score, now we have sample size is large, no? Sample size is 180, no? 180. Then if you test the normality of this writing score and or writing score first, then we can go to the reading score, analyze, descriptive statistics, please follow the process, explore data. Explore data, your answer is here. Reading, writing score. Select writing score. Then plots normality with yes, plots with test. Okay, click on OK. Now if you go to that output here, you can see this mean value, 95% confidence, 5% trim mean, median, mode. Right, now you can see here again, you can see this results, this results is significant, right? Significant. Again, if you change this variable, this parametric and unparametric values into, yes, export data into, yes, writing score or reading score. If you change this reading score and plots again, you can see significant value, right? Here, what is your null hypothesis? Null hypothesis and alternative hypothesis. There is no significant difference from the normality. Then alternative, there is a significant difference from the normality. Now here we rejected. Now we can see approximately normal curve, no? Normally distributed, approximately normally distributed. Then our answer is 0.000. Then we can see significant difference from the that means significant difference mean it is with the normality. Here also we can see, right, significant difference from the normality. Here right. Then it is easy to explain through that graph and chart, but the most important criteria is to use this test of normality, right? You can use test of normality. Right. Now after, yes, fortunately, yes, here we have non-parametric data too, right? Non-parametric data, that means non-normal data too. Now if we need to apply non-parametric statistics, example, instead of that, instead of this independent sample t-test, what is the relevant independent test for non-parametric data? Yes, Mann-Whitney U-test. Again, same case, we have male and female category with numeric variable, right? Quantitative variable. Here, if we take same same data set, writing score and gender. Now we are going to apply. Now after testing them, this is not a normal distribution. Writing score is not following normal distribution. Therefore, we can go to the non-parametric test. Non-parametric test. Then how to identify that non-parametric Mann-Whitney U test? Then analyze. Here previously we got compare means. Please refer this one. Now we need to take yes non-parametric test. Here you can see separate one as non-parametric test. You can refer them here. Non-parametric, right? Previously we got mean, compare means. Now here non-parametric test. Non-parametric test, now again independent samples. Here if you go to this one, parametric independent sample, non-parametric independent sample, right? If it is following normal distribution, we can go to the parametric independent sample, that means compare means independent sample. If it is not following normal distribution, then we can go to the non-parametric independent sample. Is it clear? Right? This is very much important concept. Actually, when you are doing research, then you should definitely concern on this matter. Right. Now click on this independent samples, then click on runs, right? Then you can select that variable. Testing variable is here. What is the testing? Reading score, writing score. You can select, right? Writing score. Then gender is the group in variable. Group in variable is gender, right? Then testing variable is writing score. Then group in variable is gender. Now you can run. Just wait. Now you can see final answer here. Independent sample Mann-Whitney U test. Again, actually no need to test here. Now your decision is to reject this one because this value is less than 0.05. No. Now your decision is given. What is the decision? Reject the null hypothesis. Reject the null hypothesis. What is that null hypothesis? There is no significant difference between male writing score and female writing score. Now we reject that. That means there is a significant difference between male writing score and female writing score. We can see the same results from parametric test as well as the non-parametric test. Right? Each and every time we cannot expect equal results. Right? But here we can see same results. Is it clear? Right. Then if we move to next non-parametric test, right? Now we test that, we got that Mann-Whitney U test. Now if we have paired sample t test, again we can use Wilcoxon Saintran test. Now we have we use one yes ANOVA test. We have a separate database now, ANOVA. There are 4 categories now. Now we can use Kruskal-Wallis test. Right? You can perform, yes, you can practice it. Please practice it. Now you know the way of conducting that. Yes, click on this ANOVA table, ANOVA database. You can open it. Right? This is ANOVA database. Then what is the process? Analyze, non-parametric test. Non-parametric test. Now under the legacy dialogues you can see yes k independent sample, 2 independent sample, here k independent sample. If you click on k independent sample, right, now your task is to select them, right. Sales is the testing variable, design is the group in variable. Now design we arrange 1 to 4. We have to define it, then click on define 1 to 4. Continue. Then you can see Kruskal-Wallis test. Kruskal-Wallis test, right? You can select it. Kruskal is automatically selected one. No? Now you can see that results. As for the Kruskal test, here you go, if you go to this one, don't use median test, I selected it, but this is the Kruskal test, right? Kruskal test, your answer is again 0.003, right? Again less than 0.05, then that means there is a significant difference between groups, designs, right? Designs, right? Then average mean rank also given, mean rank difference between, yes, you can see, you can identify them. Those are the significant factors. Right. Now if you think about another one, paired sample t-test, here, paired sample, we prepared that paired sample, no? Yes, here, this one. Yes. Pain before the treatment and pain after the treatment. Yeah, you can see. Not only this, then we prepared one document, no? Paired sample one. What is that? Which one? Ah, yes, this one. We use assume data set, no? Before and after. Before and after. Right? Then you can go to the analyze. Here, non-parametric. Here, now this is not an independent sample, related sample. Right? Then click on related sample. Right? Related sample. Then select that test in field. Right? Then you can run it. Here you can see related sample Wilcoxon sign test. Wilcoxon sign test again. Yes, we can see significant difference. But in your case, you can see different answer, right? You don't have that details, no? You may have different answer. Yeah, in my case, it is rejected. Select that variable. And before it's okay, after also select. Click on that small arrow. All right, then run. Right now, your decision. What is that decision? Related. Yes, 0.6, no? Again, same result, previous 0.65 or 66, no? Now, same result, that mean no significant difference before and after the training program, no? Performance of employees before and after the process. Is it clear? Right. Now I think you have clear idea about this. Again, if I move to this data sets, right? We discuss independent sample t-test from parametric, paired sample t-test, uh, ANOVA test, right? ANOVA test, and also that is called regression and correlation, Carl Pearson correlation. Here under the non-parametric test, we use that Mann-Whitney test, Wilcoxon sign test, Kruskal-Wallis test, and also chi-square test. Chi-square test you can use. Here you are given some details. You may have one document here. Yes, this is regarding, yes, chi-square test. Yes, chi-square test. Now if you need to measure the association between two nominal variable. What is the treatment? Contingency table, it is given by that chart, right? This is the, again you can see H0 and H1. Color preference is not related to personality. Personality also a qualitative variable, and here color also a qualitative variable. Now, if you have two qualitative variable, nominal variable, then your task is to, your intention is to measure the association, then we can use this chi-square test. Chi-square test. Color preference is not related to personality. H1 color preference is related to personality. Right? In this way, you can organize your hypothesis. Then this is the way of conducting that test. Then analyze, descriptive statistics, cross tabulation. Analyze, descriptive statistics, cross tabulations. Finally, you can see this type of table, right? This type of table. Then this is the chi-square table. Again, the same criteria. This answer is 0.000, less than. Yes, again p-value you can see. P-value less than 0.00. Then based on this, you can identify whether it is significant association or not, right? Then you can see the results from the top row of the last table. Pearson chi-square statistics is 71.2 and p-value less than 0.01. A very that means it is a very small probability of observed data under the null hypothesis of no relationship. The null hypothesis is rejected since p-value is greater than less than 0.05. What is the conclusion? Color preference seems to be related to personality. Right? Now, as per the null hypothesis, there is no effect here. Color preference is not related to personality, but we reject that null hypothesis, then we accept color preference seems to be related to personality. Is it clear? Then yes, we can think about our database. If you move to this parametric and non-parametric data sets, right? Now if we think about this socio-economic status here, socio-economic status and school type, are there any relationship or association between school types and socio-economic status? There may be no, right? Then how can we measure them? Now we cannot run Karl Pearson correlation or Spearman's Rand correlation. We cannot run because we have nominal level data. Then we can go for the analysis. Then here you can see cross tabulation, fourth one. Analysis, descriptive statistics, cross tabulations. Right? Analysis, descriptive statistics, cross tabulation. Click on this. Now you can select relevant variables for rows and columns, right? Then if you think socio-economic status for rows and type of school for columns, right? Now you can see that values, right? Statistics, chi-square. Now if you go to the statistics, you can select chi-square test. If it is needed, you can select correlation, contingency coefficients, right? Then okay. Then you can select expect results also. Right. Click on OK. Now you can see these results. This table, cross tabulation here, socioeconomic status and type of school, right? Then you can explain about this table. In addition to that, you can test. Yes, we cannot see Pearson chi-square here. Pearson chi-square. This value is 0.64. What is the decision? What is the decision? If you go to the previous one, yes, this chi-square is p value is 0.00. Therefore, we reject null hypothesis. Right? We rejected null hypothesis. But here, we don't have enough information to reject null hypothesis. That means there's no relationship between association between uh, type of uh, school and socioeconomic status. Normally we believe that, but as per the results we cannot say. Is it clear? We don't have enough information to reject that null hypothesis because this value is p value is greater than 0.05. Okay. I think we already covered. In addition to that, I can perform about that. Yes, again go to that parametric test. Now, if you need to measure the relationship between two variables or three variables, you can perform analysis, correlations, bivariate. Last time we discussed, no? No? Correlation? No. Right. Now, if you need to take correlation between two quantitative variables and normally distributed variables, then you can go to analyze, correlation, bivariate. Now you can select that variable, relationship between reading score, writing score, max score and social science score. Are there any relationship between them? Right? Then you can select Pearson correlation here. Then the relationship between reading score and writing score, reading score and max score, then reading score and science score. Now, if you give this type of table, SPSS table, then you should be able to construct hypothesis. Then, if you refer this document, there are this output, there are 4 variables. The relationship between reading score and reading score and writing score, relationship between reading score and max score, relationship between reading score and science score, right? Then if you are given that sheet, now how many hypotheses can you prepare? One is you can write one hypothesis here. There's no relationship between reading score and writing score, right? Please take down, right? Then how to, now in your examination also you should be able to construct number of hypotheses and test it through this test results output. Right. Now here you have reading score, relationship between reading score and writing score. Answer is 0.64. Then you can see 2 asterisks here. 2 asterisks here. Then 2 asterisks mean yes, correlation is significant at the 1% level. Correlation is significant. Right? Correlation is significant. Then what is your null hypothesis? There's no, please take down, there's no relationship between reading score and writing score. There's no relationship between reading score and writing score. Then alternative one, there is a relationship between reading score and writing score. There is no relationship, that is under null. Alternative, there is a relationship. Right? Then what is the decision? What is the decision based on these results? Your p value, again p value concept here. Your significant value means p value. P value is 0.000, 0.00. Is it clear? 0.00. That means reject the null hypothesis. What is the null hypothesis? There is no relationship between reading score and writing score. Then we reject null hypothesis. That what is the conclusion? There is a relationship between writing score and reading score. Is it clear? Yes. Is it clear? Sorry. Yes. No. Now go to that table. Just first of all, you need to go to that database. Go to that data. Yes. Is that so? Yes. Yes. Then go to analyze. Discrete. No. Correlation. Yes. This one. Correlation bivariate. Select that variable. Yes. Reading score, writing score, max score, science score. Select them. Then click on OK. Okay. Now Pearson is automatically selected. You can see that table, right? Is it manageable? Right. Now, what is the second hypothesis? There is no relationship between reading score and max score. There is no relationship between reading score and max score. Then alternative one, there is a relationship between reading score and max score. Then what is your decision? What is your decision? Yes, again reading score and writing score, max score. Answer is 0.660. Then 2 asterisks here. It is significant at 1% level. Then what is your decision? What is your decision? There is a moderate relationship and it is significant at. There is a moderate relationship. Moderate means around 0.6. No, moderate relationship and yes, it is significant at 1% level. 1% level. That means we have to reject null hypothesis. What is that null hypothesis? Null hypothesis, there is no relationship between reading score and max score. Then we reject that. Then what is the conclusion? There is a relationship between reading score and mathematics score. Is it clear? What is the your answer is 0.6, no? 0.6. Now you can see asterisk also. Otherwise you can refer this point. Yes, you refer this p value. P value significant value is 0.00. Right? 0.00. Right? Then relationship Pearson correlation is 0.66 with 2 asterisks. Yes, it is given two main items. First one is correlation coefficient. Correlation coefficient is 0.66. That means moderate relationship with 2 asterisks. Asterisks mean correlation is significant at 1% level. Right? Now, then actually no need to use the second column 0.00. With this statement you can conclude it. Right? Otherwise, now if you don't have this column, this row, then definitely you can read this one 0.00. Then it is significant. Significant means we have to reject the null hypothesis. Right? Then what is the decision? There is a significant relationship between mathematics score and reading score. Next one. Yes, what is the next hypothesis? There's no relationship between reading score and science score, right? Then now alternative one is there is a relationship between reading score and science score. Then final answer 0.629 with 2 asterisks. Again reject the null hypothesis. Null hypothesis. right? Now, not only that, further, if we need to test the relationship between writing score and max score, again writing score and max score, writing score and max score, again we can build a hypothesis. Now we can reject the null hypothesis, right? Further, we can construct number of hypotheses and test it through this output, right? In your examination also, you are given this type of table. Your task is to construct that hypothesis. Then you have to write what is the alternative, so null hypothesis and alternative hypothesis, and based on that results, what is your decision, right? Now here in this level, we are not computing all the things manually. Now here we need to take this type of output and we should be able to interpret that results. That is the most important thing. Now you are in the management level now, right? Then your task is to apply that type of statistics and how to interpret them. That is very much important. Right. Then if we move to the regression already discussed by Dr. Madhurapperum, right? Uh, uh, I think, do you need to run regression also? Right? Right. Okay. Now, as a revision session, now this is the recap session now. Then I will discuss that matter too. Now, regression, how to run regression. Analyze, here you can see regression, then linear, analyze regression linear, right? Then you can select dependent variable. If we assume that our dependent variable is writing score or reading score, you can decide it, right? Reading score. What are the other variables? Writing score, max score, other independent variables. Science score, social science score, socio-economic status, right? You can put number of school type, all you can enter. Then if you click on OK, now you can see this type of table. Now first table is called variable table. Now you can identify what are the dependent variable and independent. So, what is the dependent variable and what are the independent variable in this model. This is the dependent variable is reading score. All others are independent variable, type of school, science score, socio-economic status, social studies score, max score, writing score, all are independent variables. Dependent one is reading score. Right. Now, if we move to the second column, second table, this is the most important one, adjusted R square. Right. You should be able to interpret these results. Right. What is the adjusted R square here? 0.569. That means, what is the idea behind that? Adjusted R square? You already discussed that regression and correlation, right? What is the idea behind this adjusted R square? If your adjusted R square is 56.9, right? Here, this means 56.9% of changes in dependent variable is explained by selected independent variables, right? Please take down that interpretation is very much important. Now, after getting this type of regression output, then you should be able to interpret these results. Now, especially by this using this table, you can identify dependent and independent variable. Here, you need to identify model summary. Under the model summary, most important thing here, adjusted R square 0.569. 0.569 means 56.9%. 56.9%. Then you can say 56.9% of changes, 56.9% as a percentage. You can explain this, right? 56.9% of changes in what is the dependent variable? Reading score, right? 56.9% of changes in reading score is reading score is explained by selected independent variables such as type of school, science score, socioeconomic status, social studies score, max score, and writing score. Is it clear? That is the way of explaining adjusted R square, right? No need to explain all the points in this table, but most important item, that means you have to identify the significant item here. Then significant one is adjusted R square. Then if you go to the ANOVA table, this is given the overall, yes, this is given about the overall model, whether it is significant or not. Here again your answer is 0.00, again use the p value. Then this means this is a significant model. Yes, this model is significant. What is the model? Dependent variable is reading score, all other variables are writing score, then that model is significant as per this results. It is explained 56.9% as per the adjusted R square. Then last column is called coefficient table. Again we need to follow the same procedure, significant value. If it is less than 0.01, it is significant one. Here you can see this writing score, it is not significant one. Why? It is greater than 0.05. But here max score, it is a significant variable. Next one, science score also significant variable. Social studies score significant variable. But socioeconomics data status, it is not a significant variable. Yes, type of school also not a significant variable. Then there are 1, 2, 3 significant variables, 3 significant variable for this model. That means our target is to explain about the dependent variable, that is called reading score, right? We are going to explain about the reading score through number of independent variable. Among them, most important variable for explaining that reading score here is max score, science score, and social studies score. Those are the significant variable for explaining dependent variable. Is it clear? Right. Right. You have number of databases and some guidelines. You can refer them and you can practice it. Right. Again, if we move to the final stage, actually we completed number of parametric and non-parametric tests. Right. What are the parametric tests? And non-parametric test. Through SPSS, right? One is, yes, we discussed. What is that? Oh, yes. Here one sample test, t-test. One sample t-test. What is the process? Analyze, compare mean, one sample. Then we test that value, right? Whether that reading score is 50, 60 or not. We tested that, right? Then we go to the independent sample t-test. Independent sample t-test. The next one, paired sample t-test, right? 1, 2, 3. Fourth one, yes, ANOVA, analysis of variance test, analysis of variance. In addition to that, right, what are the non-parametric tests? Non-parametric test, yes, we use then chi-square test, chi-square test, chi-square test, chi-square. Next we use uh, Mann-Whitney U test, Mann-Whitney U test. Then Kruskal, sorry, uh, Wilcoxon sign rank test, sign rank test, Wilcoxon rank test. Then we use Kruskal test, right? Further we use, yes, further we use Karl Pearson correlation. Here under the Spearman's, we use under the non-parametric we use Spearman's Rand correlation coefficients. Spearman's Rand correlation coefficients. Here further we use regression analysis. Regression analysis, right, using SPSS. Wilcoxon, right? Then in your examination you may have number of questions relating to this area. That means you may have number of SPSS output to interpret, right? It is not a difficult task. It is easy to interpret them, right? Therefore, your task is to practice the existing databases. You are given number of databases. You can run them and you can perform only this area, right? Then you can run their output, then it is easy to interpret them, right? Then how to construct hypothesis and how to test them using SPSS output. That is very much important. Have you confidence about this? Right? This is not only for the examination, it is very much important for your research work, right? Actually, if you are aware with this method, easily you can complete your research, right? Right. In addition to that, yes, if you go to that previous paper, right, then you can see number of exercises like this, right? This is regarding yes, monthly average temperature and ice cream demand. Then how to prepare correlation analysis manually, right? You should be able to apply that value into the formula, right? You are given formula, right? Have you discussed how to compute correlation coefficient, right? Then you may have this type of questions. Determine the degree and nature of relationship between monthly average temperature and demand for ice cream, right? Then construct regression line. Now regression line of ice cream demand on monthly average temperature, right? You already discussed that matters manually, no? Right. Then predict the ice cream by using the existing uh, formula. Then next one, compute the coefficient of determination and interpret your results, right? Then that means coefficient of determination mean adjusted R square, right? Adjusted R square, right? Please concern about this to determine the uh, explanatory power. Then coefficient of determination or R square, adjusted R square you already discussed, no? Right? Then if your answer is 56.4%, right, or 53.6%, no? Previously we got 3.6% mean 53.6% of changes in dependent variable is explained by selected independent variables. You can put that names. Is it clear? Then this is asking about them, right? Then have you discussed this things manually? If you discuss manually, then you can expect that question, right? If it is yes not discussed, then don't worry about them, right? It is depend on your LMS. You can read them, right? Compute the coefficient of determination. It's okay. Now next question. Evaluation of two university students on 10 reliability programs in different television channel are used by the following table. Here you can see rank data, rank level data. Then have you discussed this formula to calculate that rank correlation coefficient? Rank correlation 1 minus 6d square divided by n square minus 1? No, right? It is up to you. Then if you discuss, then you can expect this kind of question. Otherwise, we are not asking that question, right? Right? You can test it. I didn't discuss that. That is under Dr. Madhura Peruma part, right? Uh, and she will include questions as per their discussion, right? Right. This is again correlation and regression related one, right? usage period in years and selling price per computer, right? Then ask question like this, right? Similar one, draw scatter diagram, Carl Pearson correlation coefficients, right? Same kind of question. Then this is regarding your assignment, right? Now I change this date as per your request. Please don't ask after that. Then I hope to allow date up to 30th, right? Then don't ask now I have two assignment at the same date. Don't, that is not a problem for me. Then I already that means flexible with your requirement, right? Then yeah, this is the regarding the previous papers. You can see some descriptive questions, right? Example for this is the previous paper, right? Year 2015, right? You can practice them. Huh? Then this is regarding probability and probability distribution. Questions regarding probability and probability distribution. If you have any doubt, you can discuss with us, or otherwise you can give a message, and you can send a message, and you can come and meet us, and you can solve it, right? This is regarding that yes, very easy topic. This is normal distribution, right? We discuss deeply on this matter. Then how to prepare this type of answer. Then you should be careful with this answer, right? Then definitely you have to draw a separate curve for each, right? This is regarding normal curve, separate curve for each, right? Then including x-axis and z-axis. Then you have to mark the answering region. Then compute that results, and you can show it, right? If you have any doubt, again we can discuss. This is table relating to that normal distribution, right? Now again you can see parametric tests are more powerful than non-parametric. Actually parametric tests are more powerful than non-parametric tests, right? However, they are mainly based on assumptions, that means parametric assumption. Then normality, there's a normal distribution, that means no heteroscedasticity, that means homogeneity of variance, right? Then autocorrelation. There are a number of assumptions, right? Yeah, this is relevant to, yes, normality test. Now normality test, you are given case test and Shapiro test output, right? We already discussed. Now using the above SPSS output, provide your comment on normality of current salary and state parametric and non-parametric test is appropriate for analyzing your data based on normality results. Now based on the results, you can say now if you reject them, normality, if you reject the normality, then it is as non-normal data, then you can go to the non-parametric test. Then you have to give that comments. Here this is regarding independent sample t-test, right? Again you can see researcher want to know whether there is a significant there is a difference between writing score of male and female. Similar question, right? Then hence independent sample t-test was applied, and SPSS output is given. Now test whether there is a statistically significant difference between current salary and current salary of male and female by here it is not mentioned. You must write your hypothesis and test it based on the results. Finally you can conclude, right? That is the process. Yeah. Next question, discuss usefulness of the following parametric and unparametric tests. There are a number of parametric tests: correlation, regression, ANOVA, Mann-Whitney U test, Kruskal-Wallis test. Yes, you should be able to discuss them. There now this is a correlation output, relationship between current salary and beginning salary, relationship between yes current salary and beginning salary key is yes 0.88, that means a strong positive relationship, and also it is statistically significant at 1% level, right? Then answer is 0.00. There is a strong positive relationship between current salary and beginning salary. We have to write it. Then we can say it is statistically significant because this significant p value is less than 0.05. Here you can see negative relationship between previous experience and the current salary. Right? You have to identify them. It is, but it is not a significant one because less than 0.0, greater than 0.05. Likewise, you can write that results. Here, test the correlation coefficients. Right? This is econometrics, that means EVU's output, regression output. I think you have discussed, no? Dr. Vasanti discussed that matter, no? Regression output using EVUs or Excel? EVUs. Then you can expect this type of EVUs output, right? Here again adjusted R square 78, right? That means 78% of changes in dependent variable is explained by selected independent variable. You can assign name, right? Here again ANOVA table show the same results, right? Coefficients. You can answer for this type of questions. Here, okay. Then these are the content of this paper. You are given 40 marks for the presentations and assignments and quizzes, right? Quizzes. Then in my assignments, I already allocated 20 marks, right, for that assignment, right? Here you are given that assignments last day. Last time I gave you this assignment. If you refer the previous one, then your task is to identify that variable and collect in data and analyze using SPSS, right? Then you can earn maximum of 20 marks from that, right? Then if you have any doubt regarding that today discussion, so the previous discussions, now you can ask, you can raise questions. Yes, we don't have any other formal discussion. Informally, you can come and ask with the relevant lecturers, ask from the relevant lecturers, and you can discuss, right? Then if you need to, that means if you need place for discussion, yes, we can arrange within a weekends, right? Weekends. If you need, we can arrange our NDC center. Weekdays it is impossible. It is because we are going to start our semester next Monday onwards, right? Right. It is up to you. You can discuss with your friends, and you can yes, if you need, then you can we can arrange that place. Right? Tell me that in advance. Tell me that date and time. Then we can arrange. Okay. Then thank you very much, and wish you all the best. Right?